This is metal scraping, an old-school manual technique to achieve high-accuracy flat surfaces as required, for example, for slideways on machine tools with very basic tooling. The scraper blades used today are typically made out of carbide, a very tough and durable material. But nonetheless, even these blades get dull sooner or later. So if you want to do some metal scraping, you also need a way to resharpen your scraper blades. A machine called the Slow Speed Carbide Grinder has established for this task. A slow-running diamond grinding disc with an adjustable table to resharpen the cutting edge at a defined angle. I first saw this type of machine in an old video from Stefan Gotteswinter, which inspired me to build my own version. My goal was to build a very small and compact pocket version of this machine, and here we are. This is my journey of building my own little slow-speed carbide grinder. As a base to start from, I bought this sheet metal electronic housing. It seemed that it had the perfect size for my project. The housing came with a few accessories: 4 rubber feet, some cables and an on-off switch. For my project, I only need the on-off switch and the feet, which I mounted directly. I started the project with the main front plate, which I made out of a piece of 5 mm thick aluminium plate. At first, I cut it to the right length on my metal bandsaw and then switched over to my new machine, a vertical bandsaw from Metabo. I bought the machine used as I thought this might be a useful addition to the shop for specific cuts the horizontal metal bandsaw can't make. The machine is made for cutting wood, but I installed a metal cutting saw blade. Normally, the cutting speed of this machine is way too high for cutting metals, but for aluminium it kinda worked. Perhaps I modify the machine in the future with a new motor for lower cutting speeds, so the machine is more appropriate for cutting metals. On my milling machine, I cleaned up all the 4 sides. As the blade is longer than the travel of my Proxon milling machine, I had to cut the long sides in 2 passes and reclamp the part in between. On such projects, the limitations of this small machine come clear. But I can reveal that there is something new coming very soon. Next, I milled a step around all the 4 sides so that the front plate can fit perfectly into the sheet metal housing. Again, I had to reclamp the part and split the cuts in 2 on the long sides. And that's the front plate with the resets milled on all 4 sides for perfect fit into the housing. Now I can mark the positions of the mounting holes. 8 M3 screws will clamp the front plate onto the housing later. Small pieces of flat steel will act as clamps to hold the front plate in place. For these plates, I have to mill some recesses around every hole drilled before. And that's the plate with the mounting holes and the milled recesses. The small clamping plates are made from a piece of 3 mm flat steel bar. I cut them to length on the bandsaw and filed some corner radii on one side with a hand file. Now the plates fit perfectly into the recesses I milled before. To finish the plates, I drilled and tapped them for M3 screws. And these are the 8 finished clamps. Next, the front plate needs some holes for mounting the 24-volt warm gear motor. Again, I marked all the positions at first, before drilling one large hole in the middle with a step drill for the motor axle and 4 smaller holes around for the M4 mounting screws. And we are ready for a short test fit with a motor in the housing. Next, I made the grinding wheel. For this, I ordered a piece of 100mm diameter aluminium disc. I was lucky to have a new 100mm four-jaw chuck with which I was able to clamp the disc in my lathe. I somehow couldn't adjust the runout better than this. Now I could clean up the front side and bore a recess in the middle, which will accept a steel mounting hub later. A large chamfer on one side should make the grinding disc look a little bit more pleasant. With the first side finished, I first made the steel mounting hub from a piece of round C45 steel bar. After finishing one side, I cut the piece on the bandsaw and reclamped the part to finish the second side. With the Proxxon IBS grinder in the lathe, I pre-drilled 3 mounting holes for the grinding disc before finishing them on the drill press. Now I transferred the holes onto the aluminium disc and finished the hub with cutting the M3 threads. I countersunk the holes in the grinding disc and mounted both parts together to finish the second side on the lathe. Unfortunately, I somehow ruined the hole diameter when reaming, and the hub had a way too sloppy fit on the motor shaft. So I made a second one with a slightly different design and a better fit on the motor. The aluminium disc I made before is actually just the backplate for the diamond grinding discs. Stefan Gotteswinter had a nice idea for mounting the discs without needing some tools to change them. 4 magnets in the aluminium plate hold the disc in place and 2 steel pins prevent the disc from rotating. I just had to drill 4 10mm holes in the disc and glue some magnets in. And that's the finished grinding disc. Next, I made the mounting plates for the adjustable table. I cut the raw pieces out of a 6mm thick aluminium plate. Again, I cleaned all the sides on the milling machine and drilled and tapped some mounting holes with M4 threads. These threads will hold the plates later onto the front plate I already made. The holes I drill here are for mounting the angle adjustment features for the grinding table. To finish the parts, I milled a very large chamfer on one corner and countersunk the mounting holes. I clamped both parts together to machine them as a pair, so that both parts will get the absolute same dimensions. The pins secured the parts to prevent them from accidentally sliding out of alignment. Next, I marked the positions of the mounting holes for the two brackets on the front plate and drilled them on the drill press. Unfortunately, I made a mistake and the holes on the left side interfered with the recess milled earlier. So I decided to shift all the 4 holes 5mm to the right side, which meant that I had to fill the wrong drilled holes with an aluminium plug. I ground the inserts flush with the surface so that the wrong drilled holes almost disappeared. After painting, this happy little accident won't be visible anymore. At least that was my plan. Next, I made the parts for the angle adjustment of the grinding table. It consists of a lower and an upper part. I started with the lower part, which I made out of a big aluminium tube. After sawing the raw part to roughly the right length, I cleaned both sides on the lathe and turned the inside and the outside diameter to the right dimensions. For machining the inside diameter, I changed to the adjustable 4-jaw chuck again. As it is a little bit tricky to bring the part into its final shape, I marked a 0 position on the lathe with a sharp thread cutting tool and glued a paper template onto the part. I did this twice as I need 2 parts, one for the left side and one for the right side. Now I cut both parts to roughly the right size on the bandsaw and finished them on the milling machine. I drilled a hole through the middle of the part for the clamping lever. With this hole as a reference, I drilled the 2 mounting holes and cut 2 M4 threads in both parts. And that's the lower angle adjustment part and how it's mounted on the table mounting bracket. The upper part of the angle adjustment mechanism is made out of a piece of C45 steel. On the lathe, I brought the part into its raw shape. A big recess hole in the middle is needed to make place for a special clamping nut later. I flipped the part over to machine the backside. That's the semi-finished part with all the lathe work done. This part was cut in 2 pieces for both sides of the table. Again, I finished the parts on the milling machine. Beside the 2 mounting holes with M3 threads, a slot in the middle of the part is needed. The slot will allow the table to swivel and clamp it in place at the same time. And these are the finished angle adjustment parts and how they are meant to work together. The only part left to complete the angle adjustment mechanism is the special clamping nut, which I made out of a piece of round steel bar. I turned the outside diameter to exactly the same dimension as the inside diameter of the steel part made before, so both parts will fit perfectly together. On the milling machine, I measured the part in and drilled and tapped a hole exactly in the middle. After this, I milled the sides of the clamping nut to the right size and removed the part from the stock with a carbide saw blade. And these are all the 3 parts for the angle adjustment mechanism. This small handle will lock the table in place. Now all we need to make is the grinding table. I made it out of a piece of precision ground flat steel. This way I already have a clean and good looking surface without having to machine it. As always, I cut it to the right length on the bandsaw and cleaned the 2 shorter sides on the milling machine. The grinding table needs a cutout on one side to make space for the grinding disc. So I drilled a hole in each corner, made the 2 cuts on the sides on the bandsaw and removed the piece in between on the milling machine using a small 3mm anvil. With the main material removed, I cleaned all the sides and milled an angle onto the long side. This is to allow the table to swivel downwards without crashing into the grinding wheel. Here you can see the sketchy setup for milling the angle with a vise in the vise. And that's the grinding table with all the milling work done. Another happy little accident here, as somehow the end mill was pulled into the workpiece and left this mark. As it is on the back side of the table, I leave it as it is. Now I just have to drill the 4 mounting holes and countersink them to finish the table. And I couldn't resist to mount the parts test-wise together to prove my concept. So far, everything seems to work. Before finish assembling the machine, I had to make a few modifications to the sheet metal housing. Some holes are already there, which I wanted to use as good as possible. For the speed adjustment knob, I just had to widen the existing hole a little bit. The switch for changing the direction of the grinding disc should be directly underneath the speed adjustment knob. For this, I had to change the existing hole into a rectangular cutout. For the main power cable, I drilled a large hole with a step drill for a cable gland. I thought it would be cool to have a handle on the top of the housing, so I bought this plastic handle and drilled 2 holes through the sheet metal. A steel plate with 2 M6 threads will secure the handle from underneath the housing. I did it this way to add some additional weight to the machine. As the housing is very lightweight and would tip over with the grinding table on one side, I made a large steel plate which will be mounted at the bottom of the housing to add some weight and hopefully counterbalance the machine. On top of this plate, the 24-volt DC power supply will be mounted. Now a few last finishing touches have to be done, countersinking the holes on the front panel and rounding its corners. And adding some nice chamfers on all the parts. Before assembly, I painted some of the parts, the sides around the grinding table, the front plate and the table mounting brackets. For painting I used blue-gray and used a sponge to apply the paint. This is a technique I learned from a machine rebuilder which works very well for small parts and give a very pleasant structured surface. And these are finally all the parts of my self-made Slow Speed Carbide Grinder. I started the assembly with filling the electronic housing. I first installed the solid steel plate on the bottom. Next, I installed the DC power supply. Next, I installed the cable gland and the main on-off switch and connected the power line. Then I installed the switch for changing the motor direction and the speed control electronic. While assembling the front plate and the table mountings, I found out that I obviously had filled the wrong holes before and the table doesn't fit now. So I had no other choice than drilling the plugs out again and living with 2 extra holes in the front plate. With this major accident fixed, I could continue to assemble the table mountings. It became clear that assembling the machine isn't that trivial. I had to remove the table again in order to mount the motor and the front plate to the main housing. Now I could install the grinding disc and the table again. I connected the motor wires to the speed controller and the machine is almost complete. Only the handle is missing and the housing can be closed again. And of course, we need a grinding disc. And this is the finished Slow Speed Carbide grinding machine. The machine is surprisingly smooth running. And let's see if it works as expected. A little bit of water helps with binding the grinding dust. The carbide grinding dust is pretty hazardous, so better don't breathe that. So far, the machine seems to work quite well. The motor isn't the strongest one, so perhaps I have to change that in the future, but for now, it works. I hope you found this project interesting. Thank you all for watching, and till next.